Hi, welcome to the video on rates of radioactive decay and half-life. This is the second half of the 1.2 notes. You should already have to show you the top half of the notes filled out. If not, make sure you get those filled out. All right, so we've been looking at ways that we can determine the relative, so that's older, younger, and absolute age, that's the age when we're dealing with numbers. And for the absolute age to determine that, we use a radiometric dating, which uses a tool that's called a Geiger counter that can detect the amount of radioactive isotope inside of a sample. And then we use that amount of radioactive isotope to determine the age. The more radioactive isotope it has, the younger it is, the less the older it is. Now, with that, scientists use a property of radioactive isotopes, which is called the half-life, because it's hard for us just to base on the amount to sort of figure it out, right? How long it took to go from, let's say, 10 grams of a radioactive isotope to 3 grams. But we have this property called a half-life because it relates the amount at which we have to the time it takes for us to get to that amount, all right? And so what is the half-life? Half-life is the time, and it's given the symbol T with a little half subscript, 1/2. The time it takes for half of a radioactive isotope to decay. Remember, if you need to, go ahead and pause the video and copy down notes. Now, one of the things that we use in half-lives is we count the number of half-life cycles, like how many half-lives have passed in a given amount of time. So we count the number of half-lives that have passed in the given amount of time. All right, let's look at some examples of how we actually analyze half-life data. There's different types of data. The ones we're going to be focusing on mainly are data tables. But you also saw, or will see, we can also use graphs or plots as well. All right, what if I wanted to find the half-life? And here we have an isotope of sodium, Na is sodium, and its mass number is 24, so we call this sodium 24. And if you look in this table, in the X column I have the time in hours, and in the Y column I have the amount of sodium 24, I assume atoms, because they're not saying grams, so this probably just means I'm counting the number of atoms. All right, so I want to find the half-life. Remember, the half-life is the time it takes for half of the radioactive isotope to decay. So what I need to do to find the half-life is I need to start at a certain amount and find out how long it takes to go from that amount to half of it, okay? So, and I'll zoom this in so it'll be a little easier for you to see. So, for example, I can say, starting at 100, how long is it going to take to go from 100 sodium 24 to 50 sodium 24 atoms? So let's go ahead and do that. So I'm at 100, and I know half of 100 is 50. That's why I chose 50. So how long does it take to go from 100 to 50? All right, and that took 15 hours, okay? So that means that my half-life here is 15 hours because it took 15 hours to do that. Now, I could choose to start at another amount as long as I had a value that was half of that. For example, I could start here if I wanted to, and the amount of sodium 24 is 79.4 atoms. And half of 79.4 is 39.7. So if I wanted to, I could do this as well, because that is half, right? So it's divided by 2, and this one's also divided by 2. And so in doing that, I can just check, okay, that would mean I would start at 5 hours, and then I would go to 20 hours. The difference here is 15 hours, and once again, it'll give me the same answer. All right, so now that we looked at this question 1, let's look at how we extrapolate. Extrapolate means when you have data that you're looking for that's not yet in the table. Okay, it's a little further along. So you kind of have to figure it out based on patterns that you see. So it says extrapolating the data to find the future amount. how much sodium-24 will be left after 30 hours? Notice we don't have 30 hours in the table. And then how much will remain after 45 hours? So let me go ahead and add those here. 30 and 45. That's where I want to go. Now, how do I figure that out? What we're going to do is we're going to follow the patterns in the X and Y column until you get to where you want to go. So let's start with the X column. You notice that what we're doing is, because the half-life is 15 hours, every 15 hours, so like if we go from here to here, adding 15 hours, that's a half-life, okay? So from 0 to 15 is a half-life. From 15 to 30, again, I'm just adding 15 hours on this side, so 15 to 30 is another half-life. That's perfect, because now what I can do is then I can go to the Y column, where the pattern here is dividing by 2. So from 100 to 50 is one half-life. We divide it by 2. We divided the amount by 2. 100 by 2 will give you 50. So that means to go from 50 to, at 15 hours to 30 hours, again, I would just divide by 2. 50 divided by 2 is 25. 50 divided by 2 equals 25. And so that's how much I would have after 30 hours. So after 30 hours, would have 25 sodium-24 atoms, okay? All right, now how about at 45 hours? Okay, once again, to go from 30 to 45, I'm adding 15 hours. 15 hours is a half-life. If another half-life has passed, that means I have to take the 25 and divide it by 2. So 25 divided by 2, which if you put that in your calculator or do mental math, is 12.5. I'm dividing this by 2. I'm just following the patterns on both sides. So on the x-axis, the time, I'm just adding 15, and on the y, I'm dividing by 2. So after 45 hours, I would have 12.5. Now, the truth is, if this is number of atoms, you can't have a half of atom. So what the best thing to do is to round it to a whole number. So I'll say 13 atoms. If this is grams, you can have a half of grams, but you can't have a half of atoms. So if these are atoms, well, we couldn't keep that as a decimal. We would have to round it up to 13. Okay, so just to recap, to find the half-life, which is the amount of time it takes for half of something to decay or to decay by half, you would start at a certain amount, and then you would have to find half of that amount in the table and figure how long it takes to go from that amount to half. So from 100 to 50, how long did that take? It took 15 hours. Then to extrapolate the data, you're going to follow the patterns on both sides. For these half-lives, for the times, you're adding the amount of time of a half-life, and for the amount, you're just dividing the y column, you're dividing by 2 each time. So to go from 15 to 30 hours, we added 15, that's one half-life, so then we just divided by 2 once. If we were going to 45 from 15, we would add, that would be 2 half-lives because we have to add 30, right? So that's 2 half-lives, so we have to divide by 2 twice, and then eventually give us the 12.5. All right, so I hope you found this video helpful, and have a quality day.